Okay, so we're back. All right, so we're given a problem. Pick the correct one of these three and make the appropriate substitution. Okay. All right, so number 2, integral of x cubed over the square root of x squared plus 4. Okay, this is easy because there's only one of them that has a plus, right? So that would be the middle one, right? A squared plus x squared. So again, a is 2. So let x equal a tan theta. So x is 2 tangent theta. What's the derivative of tangent? Secant squared. So dx equals 2 secant squared theta d theta. Now I substitute. Now when you write the dx like this, you can pretend it's on top. After all, dx is like dx over 1. So you could think of it that way. So x cubed is 8 tangent cubed, right? 2 tan theta cubed, 2 times 2 times 2 is 8, and then tangent cubed. So here's x cubed. dx is on top, 2 secant squared theta d theta. Okay, so here's my dx. I'm putting it on top. If you put it to the side here, it's like it's on top. It's like dx over 1. Okay, now look at the bottom. Radical x squared plus 4. X squared is 4 tangent squared theta. 4 tangent squared theta plus 4. Okay, factor out the 4, and you have tangent squared theta plus 1. What is tangent squared theta plus 1? Secant squared. So what did I do on top? Looks like I combined everything. So 8 times 2 is 16. Tangent cubed secant squared d theta. And on the bottom, it's 4 secant squared, whose square root becomes 2 secant theta. Right? So you can see how nice it comes out. So by making use of these substitutions, the square root disappears. Then you just have a trig integral. Okay, let's see. 16 divided by 2 is 8. Bring the 8 outside. I can cancel one of the secants. Secant squared cancels that secant. So now I have tangent cubed theta and secant theta d theta. Okay, and that looks like something we just did. So I can change that to tangent squared times secant theta tangent theta d theta. And there's an 8 outside. 16 divided by 2 is 8. Secant theta tangent theta times tangent squared. Okay, so this is of the nature, I want this stuff to only say secant theta, because the derivative of secant theta is secant theta tangent theta d theta. So I want this to only say secant. It's tangent squared. I use the identity secant squared theta minus 1. Okay, so tangent squared theta is secant squared theta minus 1. I now have stuff that only says secant theta. So I can do my u substitution. So u equals secant theta. du equals secant theta tangent theta d theta, which means all of this gets to be changed to du. And secant theta is now u, so I have u squared minus 1. Okay, and again, this is an indefinite integral, so my answer is going to be plus c. So 8 times integral of u squared minus 1, that's u cubed over 3 minus u. Change u back. What was u? U was, where'd it go? Secant theta. So right now I have 8/3 secant cubed theta minus 8 secant theta plus c. But you can't leave your answer like that because this is in theta. The original problem was x. So what do? I make my triangle. Okay, sometimes I say the word triangulate. Okay, I don't know if that's a real word in the math sense, but I'm going to triangulate. So x equals 2 tan theta. I will use that to figure this out. Okay, so calculus is done. Time for trig. X equals 2 tan theta, right? X is 2 tangent theta. Divide by 2. Tangent theta equals x over 2. Draw my triangle. By the way, your triangle doesn't have to look like that. If you like a triangle to look like that or like that, that's fine. I'm just used to doing this. But if you want your right angle to be over here, or if you want it to be over here, that's fine. Okay, tangent is what over what? Opposite over adjacent. So tangent is x over 2. So opposite over adjacent, x over 2. Do a little bit of a squared plus b squared equals c squared. The hypotenuse comes out to be radical x squared plus 4. Okay. Now, if you want a little bit of a trade secret, quite often if you look back at the original problem, you can find the answer to the missing side. In other words, the original problem had square root of x squared plus 4. It's no surprise that this would be square root of x squared plus 4. Okay. You should double check that it works. It does. Let's see if a squared plus b squared equals c squared. What is 2 squared? 4. What is x squared? Well, x squared. Add them up, x squared plus 4, which is equal to the square of this. Okay, so that works. Okay, check back over here. Okay, we had the 2 and the x. This comes out to be, if you do the a squared plus b squared equals c squared stuff, this was radical 4 minus x squared. Again, no big surprise. There's a radical 4 minus x squared in the original problem. So sometimes, it's a quote-unquote trade secret. If you want to find that missing radical quickly, just look back at the original problem. Okay. Or even just think logically. It would not surprise me if the final answer had a square root of 4 minus x squared when it integrates, and it does, right? Okay. I would totally not expect the answer to have square root of 9 minus x squared. That'd be really, really weird, right? But for the final answer to have radical 4 minus x squared does not surprise me, right? That should not surprise you. Okay, so quite often, if you want the missing side, just look back at the original problem. It's not always going to be that, but quite often it turns out to be what you see in the original problem. So it's no big surprise to me that the missing side was what? Radical x squared plus 4. I can find where it was. Yeah, x squared plus 4, because that was originally there. Okay, now what do we want? We want 8/3 secant cubed minus 8 secant. Now, secant is the reciprocal of which trig function? Secant is the reciprocal of the cosine. Remember, if one function has a co, the reciprocal does not have a co. So secant, no co, right? So reciprocal is the cosine. Cosine is adjacent over hypotenuse. Therefore, secant is hypotenuse over adjacent. So there we go. 8/3 secant cubed. So hypotenuse over adjacent. Radical x plus 4 over 2 quantity cubed minus 8 times, again, secant theta. So hypotenuse over adjacent. Radical x squared plus 4 divided by 2 plus c. And just a little bit of cleanup. 2 cubed is 8. Right? So that 8 cancels that 8. That 8 cancels this 8, 2 cubed, so I just have 1/3. And I decided to write this as x squared plus 4 to the 3/2. It's a square root of a cube, so 3/2. And then minus 8 divided by 2 is 4. Radical x squared plus 4 plus c. Final answer. Okay. All right, so that's number 2. And next one I want to show you is number 3. So you can see one of each type. Okay, so number 3. Integral of the square root of x squared minus 4 over x. X squared minus 4. All right, x squared minus a squared. That looks like the third one. So how do I substitute? X equals a secant theta. So in this case, it's going to be 2 secant theta. Okay. And of course, it's no big surprise. I mean, the first one was this one. The second one was this one. So it stands to reason that they're going to show you one of each type. Okay, so after this one, I've shown you one of each type. Number 1 was this substitution. Number 2 was this substitution. Number 3 was this substitution. Okay, so 2 secant theta. Find my dx. 2 secant theta, tangent theta, d theta. The derivative of 2 secant theta is 2 secant theta, tangent theta, d theta. Now I substitute. So instead of writing dx, I write all this stuff. Okay, here it is. Here is my dx. Dx is 2 secant theta, tangent theta, d theta. Square root of x squared. What is x squared? 4 secant squared theta. Minus 4 divided by x. X is 2 secant theta. So there it is. And take a look. If you factor out a 4, you have 4 parentheses secant squared theta minus 1. What is secant squared theta minus 1? That is tangent squared theta. Okay, so we had an identity that says it's tangent squared. So underneath the square root, I have 4 tangent squared theta, whose square root is 2 tan theta. So very nice. 2 tangent theta. Okay. And I notice very conveniently, 2 secant theta cancels out 2 secant theta. So gone, 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 gone. So I have 2 tan theta, right? 2 tangent theta times another tangent theta. So let's take out the 2 tangent squared theta. Okay. Well, we just finished integrating tangent squared theta. Look back in your notes. The trick for that is to make it secant squared theta minus 1. So 2 integral of secant squared theta minus 1. Integral of secant squared is tangent theta minus theta plus c. Okay, we can't leave it that way. That's theta, but the original problem was an x. So triangulate again. Okay, so we said x was equal to 2 secant theta. Solve for secant theta. So secant theta is x over 2. Divide both sides by 2. Secant is the reciprocal of the cosine. So if secant is x over 2, cosine is 2 over x. All right, so SOHCAHTOA, cosine is adjacent over hypotenuse. So here's theta. Adjacent is 2. Hypotenuse is x. Okay. Now, for this missing side, you can do your Pythagorean theorem. A squared plus b squared equals c squared. I think I'll just use the trade secret. Just peek back at the original. It's probably radical x squared minus 4. So I put it sideways there. Radical x squared minus 4. If you do the a squared plus b squared equals c squared, it does work. Or you can just double check. Let's double check. What do you get when you square this? Well, you just take up the square root and you have x squared minus 4, right? What is 2 squared? 4. Add them up. What's x squared minus 4 plus 4? Well, just x squared, which is equal to the hypotenuse squared. So it definitely works. All right, so now I have to write this. How do I write theta? Well, cosine theta is 2 over x. Therefore, theta is inverse cosine of 2 over x, right? You can put inverse cosine on both sides, so to speak, to get rid of theta, right? So, sorry, get rid of cosine. Put inverse cosine, that cancels out. Inverse cosine, it looks like that. Okay, so theta is inverse cosine of 2 over x. All right, so I'm ready. 2 times tan theta. So tan is what divided by what? It's opposite over adjacent. So 2 times radical x squared minus 4 divided by 2 minus theta. Theta we now know is inverse cosine of 2 over x plus c. Okay, so that's basically it. I distribute it because these cancel out. So 2 times this, that cancels out. So final answer, radical x squared minus 4 minus 2 inverse cosine of 2 over x plus c. Final answer. Okay, I'm calling this 9 star because this was from the old edition. I don't see this in the new edition at all, but it is a good problem. So I'm showing it to you, and it illustrates an important point. So I want you to look at this. And yeah, this now therefore becomes eligible for the test. I mean, this kind of a problem, since I'm showing it to you, you might get something like that on the test. Okay, integral dx over radical x squared plus 16. Okay, the first part is fairly regular, but there's something different about the answer that I need to show you. Okay, there's a plus. The only one with a plus is this one. So x equals a tan theta. Let's see, there was a 16. So if this is 16, what's a? A is 4. So x is 4 tangent theta. Dx, 4 secant squared theta d theta. Okay, again, when you go from here to here, you actually differentiate. Okay, the derivative of 4 tan theta is 4 secant squared theta d theta. Now I substitute. Dx is all this stuff. So 4 secant squared theta d theta on top over radical x squared. So 4 tan theta squared is 16 tangent squared theta plus 16, right? And now notice you can factor out the 16. This almost always happens in these kind of problems. And these substitutions make it that way. By making use of these substitutions, you get it to be the way that you want it. Again, put this on your cheat sheet for the next exam, okay? Unless you want to memorize it. I don't think you want to memorize it. Okay? And side note, if we were meeting face-to-face, I would still give this to you. I wouldn't make you memorize this. Okay, so the last time I taught the class, I gave them these formulas. Okay, so anyway, so factor out the 16, and then you have tangent squared theta plus 1. Tangent squared theta plus 1 is secant squared. Perfect. It's a perfect square. So on top, I have 4 secant squared theta d theta. The bottom is radical 16 secant squared, which is now 4 secant theta. Nice. Well, 4 cancels to 4. I can cancel out a secant. So I'm doing just integral of secant theta d theta. Okay? And we just talked about this. This is one of those new ones, and you don't have to memorize it. If we were meeting face-to-face, I would actually make you memorize it. But that's one of the special integrals. Okay, it came out to be ln absolute secant theta plus tangent theta plus c. Okay, so right now, ln absolute value, secant theta plus tangent theta plus c. Now I have to triangulate. You can't leave your answer like that, because what was the original problem? X. You got theta, so I have to change it back to x. How do I do that? I take this relation, x equals 4 tangent theta, and do my triangulation. Okay, so calculus is done, time for trig. Okay, so x equals 4 tangent theta. Isolate the trig function. So divide by 4. Tan theta is x over 4. All right, SOHCAHTOA, tangent is what divided by what? Tangent is opposite over adjacent. So put my theta, opposite, x, adjacent, 4. Okay. Now, I know you already saw it, but pretend you didn't see it. You can do your Pythagorean theorem to find the hypotenuse, or you do the trade secret. Peek back at the original. I'm going to guess it's radical x squared plus 16. You're almost always right. Okay, let's just say there are cases where you're wrong, but more than half the time you're right if you just peek back here and say that's got to be the missing side. Okay, square root of x squared plus 16. But again, it's a good idea to double check. Let's check. Is it true that a squared plus b squared equals c squared? So what is this squared? X squared. What is this squared? 16. Add them up. X squared plus 16. Is it equal to this thing squared? Yes, it is. All right, so now ln secant theta plus tangent theta. Okay. Now, secant is hypotenuse over adjacent, because cosine is adjacent over hypotenuse, right? Well, we just did something like that, right? Secant is hypotenuse over adjacent. So here we go. Hypotenuse, radical x squared plus 16, over the adjacent, which is 4. Okay, so what am I doing? I'm plugging into ln absolute secant theta plus tangent theta. Secant is hypotenuse over adjacent. So square root of x squared plus 16 over 4. Okay? And then plus tangent theta. What's tangent? Tangent is opposite over adjacent. Okay? Plus x over 4. Okay? So at first glance, this is what I have. ln absolute value of x squared plus 16 over 4 plus x over 4 plus c. I would actually take that as a final answer. Okay? But look at what I did for the final answer. How did I go from here to here? Okay, so I wanted to show you this. First, I can write this as ln radical x squared plus 16 plus x all over 4, right? Okay. I know what I do. I can sneak that over here. Yeah, why don't I just write it? Okay, so that's the same as that. Okay, how do I go from here to here? It looks like I lost the 4. Well, I'm taking ln of a quotient. It's ln of something divided by something. We have a property of logs, it says I can write it as ln absolute x squared plus 16 minus ln absolute 4 plus c, right? Ln of a quotient is ln of the top minus ln of the bottom. Negative ln 4 is a real number. If you add it to c, it's still just another constant. So you can absorb the minus ln 4 with the c. So that's how you can get rid of that. Oops, I forgot the plus x. Okay, so one more time. C minus ln 4, absolute value 4 is 4, is the same as c. C can be any real number. So c minus ln 4 is also any real number. Okay. Now, how do I go from here to here? It looks like I just dropped the bars. When can you just drop the bars? Well, if the expression is always positive. Okay. I claim this expression is always positive. And how can I claim that? Okay, so try to follow this logic. Okay, do you agree with me that if x is positive, this is definitely positive, right? If x is any positive number, squared plus 16 square root, that's positive, plus a positive, that's definitely positive. Okay, so we know it's true for positive. How about for 0? What happens if I plug in 0 and 0? Well, that's nothing. I'm taking square root of 16, which is 4, so that's positive. Okay, so the only question is what happens if I have a negative? Okay, so what if I have a negative? Right? The key thing is notice this is under a square root. Suppose I plug in, let's say, negative 2. Put a negative 2 there. Negative 2 square root is 4. Okay, so pretend I don't have the plus 16. Temporarily pretend there's no plus 16. Plug in negative 2. That's negative 2. What is negative 2 squared? 4. Square root of 4, 2. You would have 2 plus a negative 2, 0. Right? So right now, these are equal in value, except this is going to be a negative. That's a positive. Same thing if I plug in 7. Oh, sorry. We already took care of all positives and 0. Negative 7. Put a negative 7 there. Put a negative 7 there. What's negative 7 squared? 49. What's the square root of 49? 7. That would be 7 plus a negative 7. It's 0. So if I don't put this plus 16, these are going to be opposite in sign. Negative 10. Put a negative 10. Negative 10 squared 100. Square root of 100, 10. It'd be 10 minus 10. They are 0. So these two are same in magnitude. By putting the plus 16, this will always be bigger in magnitude than this. So I claim this expression is always positive. Okay, so that allows me to drop the bars here. So that ultimately is the best final answer. All right, so that was extra. Just thought I'd share with you that. If you leave it like this, that's fine, but I'm supposed to show you extra things whenever possible. So there it is. I showed you an extra thing. Okay. All right, I want to show you 5 star, which was not in the new book, I noticed, but in the old book, but it shows you how to do a definite integral. Okay, so definite integral, radical 2 to 2, 1 over t cubed, radical t squared minus 1. Okay, t squared minus 1. T squared minus 1. Well, x is functioning like t, so that would be this one. Third one. So let x be 1 secant theta. Okay, so t equals secant theta. dt is secant theta tangent theta d theta. Okay. Since this is a definite integral, I change the limits. Okay, so t equals radical 2. Radical 2 equals secant of theta. Okay, I don't like secant. I like the reciprocal better. What's the reciprocal of the secant? Cosine. So flip both sides. If two things are equal, the reciprocals are equal. So 1 over secant, cosine, 1 over radical 2. 1 over radical 2 is radical 2 over 2. What familiar angle do you know of where the cosine of that angle is radical 2 over 2? That would be pi over 4. So this is going to be pi over 4. Plug in t equals 2. Right here. Secant of theta is 2. Take the reciprocal. Cosine of theta is 1/2. Okay, that is 60 degrees or pi over 3. So theta is pi over 3. So for my new integral, I'm going from pi over 4 to pi over 3. Now I substitute. dt is on top. If they put it off to the side there, it's like it's on top. So dt is this mess, secant theta, tangent theta, d theta. That's on top. T cubed. T cubed is secant cubed. Radical t squared minus 1, secant squared minus 1. What is secant squared minus 1? Tangent squared. What is the square root of tangent squared? Tangent. Okay, and it's perfect. Notice the bottom now has tangent. It cancels out that tangent. Okay, so one more time. This is tangent squared underneath the radical, right? Secant squared theta minus 1. Tangent squared, square root of that is tangent. So that tangent cancels that. And now I have secant theta over secant cubed theta. If you cancel one of these out, you have a secant squared on the bottom, right? These two, secant squared on the bottom. Secant squared on the bottom means cosine squared on top. So I have cosine squared. We just did that. That was the case of integrating with sines and cosines, and you had an even exponent. So we have to use that substitution, 1 plus cosine 2 theta over 2. And there we go. Take out the half. Integral of 1 is theta. Integral of cosine is sine. And then by the chain rule, there's a 2 theta here. So if you were differentiating, you would multiply by 2. Since I'm integrating, I multiply by a half. Okay. And now it's just some heavy-duty trig. It really doesn't come out nice, unfortunately. But pi over 4, pi over 3. So here we go. Plug in pi over 3, 1/2 pi over 3 plus 1/2 sine of 2 pi over 3 minus parentheses pi over 4 plus 1/2 sine of 2 pi over 4. 2 pi over 4 is pi over 2. Okay, now what about all this mess? Okay, I'm trying to show you here. The sine of 2 pi over 3 comes out to be radical 3 over 2. Okay, if you look on your unit circle, if you recall your unit circle, pi over 3, 2 pi over 3. The y coordinate is more than halfway. It's radical 3 over 2. So that's radical 3 over 2. Sine of pi over 2, 90 degrees, is 1. Okay, so I plug everything in. So 1/2 pi over 3 plus 1/2 of radical 3 over 2. That's radical 3 over 4. Minus pi over 4 plus 1/2 times 1. Okay, and again, you should show me this, even though it's mostly just arithmetic. So common denominator here, 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 and here is 12. So I have a half out in front. So common denominator is 12. So multiply this by 4 over 4, 3 over 3, 3 over 3, 6 over 6. 4 pi plus 3 radical 3 minus 3 pi minus 6. You get this monstrosity. So bottom is 2 times 12, 24. Top is, okay, 4 pi minus 3 pi is pi. And you just copy the rest. Plus 3 radical 3 minus 6. So the final answer is just that. Pi plus 3 radical 3 minus 6 all over 24. Okay. So that is that one. Okay, so let's back and show you more. Okay, 15, and I believe 15 was an actual problem. Check, yes it is. This one's an actual problem. And once again, it's a definite integral. Okay, unfortunately, they give us more than one letter, x squared and a squared, but dx names the variable. That means a is a constant. You treat a as a constant. So integrating as x goes from 0 to a, I snuck in a little x equals here to remind you you're actually plugging in for x here. All right, a squared minus x squared. A squared minus x squared is the first one. Okay, so I'm going to do that one. X equals a sine theta. That's perfect. They left it as that, so I just used a sine theta. A is a constant. Dx equals a cosine theta. d theta. Now, I plug in when x is 0, what's theta? When x is a, what's theta? Okay, so put a 0 here. Well, it doesn't matter what a is. Sine of theta has to be 0. So the sine of what nice angle is 0? 0. Okay, if x is a, put an a here. A equals a sine theta. Divide both sides by a, and you have 1. 1 equals sine of theta. So what nice angle has a sine that comes out to be 1? That's 90 degrees, or pi over 2. Okay, so my new integral goes from 0 to pi over 2, like this. Okay, so I have x squared. So what's x squared? A squared sine squared theta. There it is. Oh, sorry, there it is. There's x squared. A squared minus x squared. A squared minus this thing squared. So what is this thing squared? A squared sine squared theta. Okay, so there's x squared, a squared minus x squared. Okay, and notice the same trick. You can factor out an a squared, giving you 1 minus sine squared. What is 1 minus sine squared? Cosine squared. And then, yeah, hanging off at the end is dx. What was my dx? A cosine theta d theta. Here's dx. Okay, so here's x squared. A squared minus x squared comes out to be a squared parentheses 1 minus sine squared theta times a cosine theta d theta. That's my dx. Okay, so we know this is now a squared cosine squared theta. That stays the same. I left that alone. So that's the same as that. That's the same as that. This becomes a squared cosine squared underneath the radical. And then when I take the square root, I'm left with a cosine theta, which is perfect. So now what do I have? I have a squared sine squared theta. This is a cosine theta times another a cosine theta. So a squared sine squared theta times a cosine theta times another a cosine theta. I've got a grand total of a to the 4th. A squared times a to the 4th. I now have the integral of sine squared cosine squared. We just did that. Right? And again, that was that case of the harder scenario where the only exponents you have are even. They're both even. So I'll run through that again. You know, it's nice reinforcement, I suppose. Okay. So we're just kind of retracing our steps here. All right, so a to the 4th, sine squared, cosine squared. The identity is sine squared theta is 1 minus cosine 2 theta over 2. Put that on your cheat sheet. Cosine squared is 1 plus cosine 2 theta over 2. Put that on your cheat sheet. Although if we were meeting face to face, I'd make you guys memorize it. But anyway, we just did this integral, right? So we're just seeing it again. Okay, take out the 1/4, right? There's a 1/4 on the bottom. Remember, you can always take constants in and out, not variables, but constants. So a to the 4th over 4. And 1 minus cosine 2 theta, 1 plus cosine 2 theta. That's 1 minus cosine squared 2 theta. You've seen that before. 1 minus cosine squared is sine squared. So I have sine squared 2 theta d theta. So I use the identity for sine squared of an angle. We just sort of did that over here. So sine squared of an angle is 1 minus cosine of double the angle. 1 minus cosine double this angle divided by 2. So what is double 2 theta? 4 theta. So a to the 4th over 4, 1 minus cosine 4 theta divided by 2. Okay, that pretty much does it. 4 times 2 is 8 on the bottom. So a to the 4th over 8. Integral of 1 minus cosine 4 theta, d theta. All right, so what's the integral of 1 d theta? Theta. Integral of negative cosine is negative sine. So negative sine 4 theta. Then by the chain rule times the 1/4. Again, if you were differentiating, you would multiply by 4. Since you're integrating, you multiply by 1/4. 0 to pi over 2. And again, a double check is to take the derivative, right? What's the derivative of this? Derivative of theta is 1. Derivative of negative 1/4 sine 4 theta is negative 1/4 cosine 4 theta times 4. Times 4 means you knock out to 1/4, and you have that back. Okay, when you plug in 0, you do get 0. Put a 0 there, that's 0. And sine of 0 is 0, so that's nice. And well, we already did this integral. Plug in pi over 2. Put a pi over 2 right there. Put a pi over 2 right there. 4 pi over 2. 4 pi over 2 is 2 pi. The sine of 2 pi is 0. So that's 0, that's 0, that's 0. Okay, so the only thing I have left is just this. So a to the 4th over 8 times pi over 2. Final answer, pi a to the 4th over 16. And there we go. Okay, that's that one. There's only one more of this type that I want to show you. I may not finish it today, or I might start it and then stop. What time is it? Oh, it's not even 9. So we might finish a little early today. But we'll see how it goes. 27 was a little bit different. And then let me check. Yeah, that matches your 21. It looks pretty innocent, but it's actually much tougher than you might think. Square root of x squared plus 2x. So how do you do that one? The game I'm going to play is, I wish there was a plus 1. Because if it was a plus 1, I can factor. So it's sort of like completing the square, right? Take half the coefficient of x squared. Okay, half of 2 is 1. 1 squared is 1. So I'm going to go plus 1 minus 1. That's fair, right? That way I can factor this into x plus 1 quantity squared. Okay. Or again, you can think of completing the square. Half of 2 is 1. 1 squared is 1. So plus 1 minus 1. So I've added 0. So I can write it as x plus 1 quantity squared minus 1. Okay. And if you're not sure about that, multiply this back out. If you multiply this back out, it's x squared plus 2x. Here it is. Plus 1 minus 1. So it's x squared plus 2x. So it's definitely the same thing. Okay, what you want to do now is pretend this is t, another letter like t squared minus 1. That way I can make it look like this. You see? Okay. So let t equal x plus 1, dt equals dx. So why don't you use u? Well, I might need it for later. So this becomes t squared minus 1 dt. Okay, now it's perfect. T squared, t is functioning like x. T squared minus 1, that's like x squared minus 1. So I'm using this substitution. T equals 1 secant theta. So t equals secant theta. dt equals secant theta tangent theta d theta. Okay, so put secant theta right there and change dt to this whole thing, secant theta tangent theta d theta. Okay, so there's the dt. Radical secant squared theta minus 1. Okay, put that in. And what is secant squared theta minus 1? Tangent squared. Perfect. Because what's the square root of tangent squared? Tangent. So I have tangent theta, secant theta, tangent theta, d theta. So now I'm down to trying to integrate this thing. Secant theta, tangent squared theta, d theta. Okay, now let's see. It's going to take a while to finish this. What time is it? Almost 9. Oh, okay. Let me just finish this problem. So we only have one more problem, but there's a lot more to do it. But I see I've got about 25 minutes. Okay, so I'm done after this, but don't get your hopes up too high. It's going to take a while for me to finish this one problem. Okay, so yeah, let me finish it, and that gets me ahead again, quote unquote, in case something goes wrong, which we already know has already happened to me. All right, so how do I integrate secant theta tangent squared theta? All right, so first I change this to secant squared theta minus 1. Okay, so I got tangent theta, secant theta, tangent theta, d theta. Secant theta, tangent squared theta. Change tangent squared to secant squared theta minus 1. Okay, distribute secant cubed minus secant theta. Okay, I'm going to call that I1 and I2. Right, so I always refers to the original integral, I1 and I2. So I1 is secant cubed. I've got to figure out the integral of secant cubed minus I2. Okay, so I is I1 minus I2. Okay, I2 is pretty straightforward. Integral of secant theta, that was one of the new ones I showed you. You can put it on your cheat sheet. Integral of secant is ln, absolute value of secant theta plus tangent theta plus C2. You say, what happened to C1? I could put C1, but since this is I2, I decided to call it C2, just so you don't get mixed up. I figured out I1, I'll put plus C1. I2, I'll say plus C2. I3 will be plus C3 and so on, so not to mix them up. Okay, so whenever you have more than one integral, call it C1, C2, C3. But in your final answer, right, your final answer is always just going to be plus C. Okay, so the hard one is I1. Figure out the integral of secant cubed. Okay, so how do I do integral of secant cubed? Well, I split it into secant times secant squared. And then I decided, let's integrate by parts. So we're reviewing integration by parts, which was a while ago, or more than a week, because I gave it to you even before the test and even before my internet went down last week. Okay. Now, I'm okay integrating this, right? I could integrate secant, but it's messy. I like integrating secant squared because it's tangent. So I'm going to let this be my dv, and this is u. So it's a quick review of the integration by parts. Okay. Remember, on Thursday, I'm going to give you a quiz, and the quiz is the same quiz as I would have given you last time, so it would be sections 1 and 2, perhaps. And just like before, I'll stop, break you up into your breakout rooms, and it isn't due until, what, the following Tuesday? Okay, so u equals secant theta, dv is secant squared theta d theta. Okay, so you have the formula for integration by parts. Okay, I'll write it again for you. Integral of u dv equals uv minus the integral of v du. Okay. If we were meeting face-to-face, I would make you memorize it, but we're not. So maybe there's a lot of advantages that you're not taking me in a regular semester. I'm not having you memorize stuff. Okay, so u is that. U is secant theta. dv is secant squared theta d theta. So differentiate this side, integrate this side, you might recall. So du equals secant theta tangent theta d theta. V is equal to tangent theta. So I1 is uv minus the integral of v du. So u times v, secant theta tangent theta, minus the integral of v du. So v is tangent theta. Du is secant theta tangent theta d theta. Okay. And let's see, where did I get this from? This is just the original I, notice. So it's one of those that cycle back on itself. Integral of secant theta tangent squared theta. That's I. So I1 is secant theta tangent theta minus I, the original integral. Okay, so I can plug that in for I1 now. Okay, so I was I1 minus I2. So I plug this in for I1 right there. And I2, I plug in this thing. Okay, so this thing right here goes there. I2, this thing goes right there. Okay, so I'm going to go up now for that. So I was I1 minus I2. So here it is, secant theta, tangent theta, minus I, minus I2, ln absolute secant theta plus tangent theta plus C2. So in retrospect, I didn't need a C2, I just needed a C, but sometimes you don't know that ahead of time. Algebraically solve for I. So there's an I on the left, there's an I on the right, add I to both sides. So 2i equals all the rest of the stuff. Secant theta, tangent theta, minus ln, absolute secant theta plus tangent theta, plus C2. And then divide by 2 or multiply by half. Okay, so I is 1/2, parentheses, secant theta, tangent theta, minus ln, absolute value, secant theta plus tangent theta. And now I can just say plus c. I don't have to worry about C2 or C1 or whatever, plus c. Okay, so the calculus is done, and now the rest is trig. Okay, notice the original problem. Only x. So I have to use some trig to go from there, right? So secant theta, let's see. Secant theta is t, which I'm going to write as t over 1. Okay, now, I don't like secant. I'd rather do reciprocal. The reciprocal of the secant is the cosine. So cosine theta, 1 over t. All right, cosine is what over what? So ka toa, adjacent over hypotenuse. So the adjacent side is a 1. The hypotenuse is t. Okay, so how do I figure out the opposite side? You can do your Pythagorean theorem, a squared plus b squared equals c squared, or again, use the trade secret, peek back at what I had. Somewhere I had a t squared minus 1. So this is the square root of t squared minus 1. Okay, double check. What is this thing squared? Well, just take out the square root, t squared minus 1. What is this thing squared? 1. Add them up, t squared minus 1 plus 1. 1's cancel out, you just have t squared, which is equal to the hypotenuse squared. So it fits. Okay, so we're almost there. So we have 1/2 all this stuff. Secant theta, tangent theta, minus ln, absolute secant theta plus tangent theta. Let's see. Okay, secant, well, we already have it here. It says so. Secant is t. Tangent, toa, T-O-A. Tangent was opposite over adjacent. So radical t squared minus 1 divided by 1. Well, if you divide by 1, you don't have to put it. So t times radical t squared minus 1. Minus natural log absolute value of secant theta plus tangent theta. We just did that. Secant theta was t plus radical t squared minus 1. Okay, and believe it or not, we're still not done. We actually had to substitute twice. The original problem wasn't even in t. It was in x. Okay, so this is an example where you actually have to do 2 substitutions. We went from x to t to theta. So by subbing back, we went back from theta to t, and now back to x. Okay, so what is t equal to? T is x plus 1. So put x plus 1 right there, right there, right there, and right there. Clean it up, and then you're done. Okay, so that t becomes x plus 1. That's x plus 1, but you might as well write it the normal way. That originally came from radical x squared plus 2x, right? Okay, so you should write it that way. Okay, again, t was x plus 1. Well, that's how we got it here in the first place, right? So if I go x plus 1 squared minus 1, right, the 1's would cancel out, and you just get back your x squared plus 2x. So write it as radical x squared plus 2x. Okay, and then minus ln, absolute value of x plus 1 plus radical x squared plus 2x plus c. And that's your final answer at long last. So there we are. Okay, so good. I was able to finish this problem, which means I don't have to do it next time. And there we are there. Okay, so that is that, folks. What time is it? It's not even 9:10. Okay, let me stop sharing for now. And let me check the chat. And nothing I see in the chat. Okay, so does anybody have any questions for me now? You can either unmute yourself or send it in the chat. If not, I think we're done.
Yeah, sorry, I was wondering if we could go over number 15 again, just the latter half of it.
Okay, so latter half of 15. Okay, so let me get that there. Oh. Uh-oh. Oh, I think we're good. I think we're recording. Yeah, we're still recording. Good. At first I thought I forgot to record. Oh, you know what? Oh, okay. I never turned off the recording. So if you're going to look at the recording, it even records the break, the 10-minute break. So sorry about that. Well, that's not that bad. That's better than not recording at all, right? I forgot to turn off the recording. So we were recording the 10-minute break, but I guess that's better than turning it off and forgetting to turn it back on, right? So when you look back at the video, sorry, there's that 10-minute break in there also, but oh well. Okay, latter part of 15 again. Okay, how far down did you want me to go, or 15? Was there a certain part you wanted me to do?
Just like the second half of it, I guess.
Second half? Okay, maybe I'll point here, or
Yeah, right around
maybe
there.
right here. Okay, so this is where we substituted everything. So
Mhm.
x squared, right? A sine theta times itself is a squared sine squared theta. That's the same thing here and here. And then dx. Dx is a cosine theta d theta. So there it is, a cosine theta d theta. That's my dx. And notice the square root comes out nice, because if you factor out the a squared, that gives you parentheses 1 minus sine squared. 1 minus sine squared is cosine squared. So I have the square root of a squared cosine squared. And what is the square root of that? A times cosine theta. So it's nice. So I have a squared sine squared theta times this, which used to be a real messy square root, but now it's just a cosine theta, times another a cosine theta d theta. So that gave me a squared times another a times another a. That's a total of a to the fourth. Sine squared cosine times cosine, cosine squared, and a to the fourth comes outside. Okay, and the rest of this is exactly like the problem I did earlier. Okay, so I went through all that again, but you change sine squared to that. You don't have to memorize it; just put it on your cheat sheet. Change cosine squared to that. That gives me a 4 on the bottom. Distribute that, you get 1 minus cosine squared, which is sine squared. Sine squared 2 theta. So I use the same identity. So when you have sine squared of an angle, you go 1 minus cosine of double the angle. So you double 2 theta, 4 theta divided by 2. And that gives me a to the fourth over 8. And then 1 minus cosine 4 theta. Integral of 1 is theta. Integral of negative cosine 4 theta is negative 1/4 sine of 4 theta. And just plug everything in. And then it ends up being that. Okay.
All right, thank you.
All right. Okay, you're welcome. Anybody else, please? Check the chat. Okay, I think I've caught up with the chat. Okay. Anybody else with
Yes.
anything?
Also for question 15, I'm just confusing. How did you get the pi over 2 for theta?
How to get the pi over 2 for theta. Okay. Let's see. All right, so the original integral was from 0 to a for x. I have to find out what happens with theta. Okay, so I have x equals a sine theta. Okay, so x equals 0. Put a 0 right here. That means sine of theta has to be 0. Okay, so from trigonometry, what nice angle has a sine that comes out to be 0? Well, that's right over here. That means the y-coordinate is 0. And what is that angle? That angle is 0. So theta stays 0. Okay, and then if you plug in x equals a equals a sine theta, right? A equals a sine theta. Put an a right there. Divided by a, 1 equals sine of theta. So what is that angle? That's 90 degrees or pi over 2. That's right over here. The y coordinate, sine of theta gives me the y coordinate. Y coordinate is 1 up here. Where's here? Pi over 2. That's why theta is pi over 2. Okay.
Okay, thanks.
All right. Anybody else, please? No? Okay, we'll call it a night. All right, so thanks, everybody. So next time, I'll start 7.4, and we are going to have a quiz. I'll keep the same quiz as I gave last week, so it'll be integration by parts, section 1, and maybe some of 7.2 stuff. So again, after a while, I'll stop, like, I don't know, 9 o'clock or 8:50, whatever, break you out into your breakout groups, and then you can help each other out, but it's not due until the following Tuesday. All right? Okay, that'll do it for tonight, folks. So everybody have a good night, and we'll see you on Thursday. Okay? All right, bye, everybody. Good night.
Good night.
Thank you.
Thank you.